In this part of the experiment, we're going to be given an unknown solution of hydrochloric acid, and what we want to do is figure out the concentration of that solution. The nice thing is now we've already calculated the concentration of our sodium hydroxide solutions. So we can use the sodium hydroxide to titrate the hydrochloric acid solution and use that known concentration to figure out the unknown concentration. We have our equation here. So we're again reacting hydrochloric acid with sodium hydroxide, so it's an acid-base reaction, and we're producing table salt and water. Here's the concentration of our sodium hydroxide solution determined in part 1. So what we're going to be using is the average concentration from part 1. Here's how we're going to set up our titration. Since we're working with a liquid now, we're going to use a volumetric pipette to accurately measure out 25.00 milliliters of the HCl solution. So you're going to use the pipette and you're going to dispense that directly into your Erlenmeyer flask. So for our trial 1, 2, and 3, again we want to figure out our precision. So we're doing 3 different trials, but we already know the volume of hydrochloric acid solution we're using in each trial since we're using the pipette. So that we can just fill in 25.00 across the board. Again, in the end, what we want to figure out is the molarity, same as concentration, of the hydrochloric acid solution. So once we have our hydrochloric acid in the Erlenmeyer flask, we're going to add our phenolphthalein indicator and then titrate with sodium hydroxide. The first thing we want to figure out is the liters of hydrochloric acid used. Again, since we're working with concentration that has units of moles per liter, we have to convert to liters. So for each of these, let's go ahead and move the decimal 3 times. We know that there are 1,000 milliliters in every liter. That gives us 0.02500 liters for each one. Remember again that we have to keep the same number of significant figures. So we have 4 to start with, we have to have 4 in the end. So we need the zeros at the end. So once we did our titration, we have 2 different readings. We took our initial burette reading at the very beginning before we did our titration, and we took the final burette reading. Now to figure out the amount of sodium hydroxide used, we can just subtract. So again, that will be our final burette reading minus the initial. Let's plug in our numbers and we get 42.60 milliliters minus 17.20 milliliters. Again, recall that for each of our measurements in the burette, we have 2 places after the decimal. It's always going to end with either a 0 if it's right on the line or a 5 if it's anywhere in between the small lines. So when we calculate this out, we get 25.40 milliliters of sodium hydroxide used in our titration. So we're almost there. We know the liters of hydrochloric acid used. We need to figure out the moles before we can calculate concentration. The nice thing is, now that we know the concentration of our sodium hydroxide solution, we can use that as a conversion factor to convert between volume and moles. Let's do just that. So here's our roadmap. We're going to start with milliliters of sodium hydroxide. In order to use the concentration as a conversion factor, we have to first convert to liters, then we can go to moles of sodium hydroxide, and finally we can use our balanced equation to go to moles of hydrochloric acid. Let's go ahead and write this out. So if we start with 25.40 milliliters, make sure we label it as sodium hydroxide so we don't get it confused. Then we need to convert to liters first. We know that for every liter there are 1,000 milliliters. And again, we want to make sure we label this as sodium hydroxide per 1 liter of sodium hydroxide. The next thing is we're going to use our concentration. Again, concentration are in moles over liters. So the next thing we need to do is put in for every 1 liter of sodium hydroxide, we calculated that we have 0.2137 moles of sodium hydroxide. Now we can use our balanced equation. Let's look back at that. The nice thing is our ratio is 1:1. So for every mole of sodium hydroxide, we're going to react with 1 mole of hydrochloric acid. So we can put that into our calculation. For every 1 mole of sodium hydroxide, we react with 1 mole of hydrochloric acid. If we calculate this out, what we get is 0.005428 moles of hydrochloric acid. So we're almost there. The last thing we need to calculate is our molarity, or concentration, of hydrochloric acid. So our units are always going to be moles per liter. So what we need to do is take the moles that we just calculated, 0.005428 moles of hydrochloric acid, and we want to divide by the volume. If we go back and look, we started with this many milliliters, so we need to make sure we're using liters. That's how many liters of hydrochloric acid we used. So if we plug that into our calculation, we get 0.02500 liters of hydrochloric acid. Notice that we should have 4 significant figures in our answer. If we calculate that out, we get 0.2171 moles per liter of hydrochloric acid. Another way we could write this is 0.2171 molar HCl. As we did in the other experiment, we want to do 3 different trials to look at our precision. So once you do your 3 trials, if your values differ for the molarity more than 0.005 molar, you need to repeat a trial. Once you get 3 good trials, you can go ahead and move on to calculating the average. And this is what you'll report on one of the green slips to turn in. Again, when we're trying to find an average, we want the sum of the trials divided by the number of trials we have. So these are our values for our concentration we got. We want to take 0.2171 molar plus 0.2170 molar and add the last one, 0.2168 molar. And since we have 3 different trials, we want to divide by 3. Once we do that, our average is 0.2170 molar.